sprinter needs power, explosiveness out of the blocks. It's about generating force quickly at a high rate. My PhD is part of a bigger project called Elite to High Street. It's about using rapid manufacturing technology to personalise footwear. I'm very much at the elite end, focusing on sprinting.
It's difficult to measure performance because you've got so many factors. You may have slept a little bit better, eaten different food, so it's really hard to measure that. But when you get in the lab environment, it's more easy to replicate the performance parameters. You can really see where you're getting the benefit from.
All stretched off?
Yeah, fine.
Every sprinter is different and every technique is different. People run faster for various reasons. And what I'm doing is I'm taking the shoes of a range of different stiffnesses, getting Brad in the shoes, measuring things such as joint moments, powers, torques and mechanical energy at those joints to get the stiffness of the shoe matched to the musculoskeletal performance of the athlete. You need to be impacting in here and then bouncing and then off again. Go. Excellent. The key thing for the shoes is having the right stiffness so he's generating power efficiently. That is really crucial. If you put these ones on for me, you're superb. And then what we'll do is we'll do that one more time. And it's important it's a repetition of the same movement as you were doing before. Try and keep it as consistent as possible. And go. Brilliant. And good data, good data. What you're seeing here is the point where you're contacting the ground, the force is obviously increasing. And then as you've taken off, the force is sort of decreasing to the point where there's zero force, and that's where you've actually taken off. It's really quite important to be closely associated with the guys in rapid manufacturing. I pick up the phone to Neil, he comes over, and the main things we're discussing are problems, perhaps, that we could foresee with the manufacturing process. If we offset that a little bit, increase it on the internal.
But then you're adding this extra feature just to provide the extra stiffness whilst not adding too much in the way of weight. Rapid manufacturing is actually a family of different technologies. Laser sintering is one of these technologies used particularly in high-end niche applications. For example, it's on the space station, on fighter aircraft and in Formula One cars. When Dan has given us a computer-aided design model, we need to take the actual file, we actually slice it into very thin layers, and then we take that file, put it into the laser sintering machine. The machine would then work by taking a layer of powder and scanning a laser to draw the first layer of the part that we want to make on the surface of the powder. Wherever the laser scans, it causes adjacent particles to heat up and melt and stick together. We deposit another thin layer of powder over the top. The process continues layer by layer until a full 3D product has been made. When the machine has finished sintering, we brush away the loose powder where the laser hasn't scanned, and what we find inside is the outsoles of the sprint spikes where the laser has scanned.
Hi, Brad. These are hot off the press.
As you get to that final level of elite performance, with everybody looking for that edge, the differences between first place and second, third, fourth is such a small margin. Sports equipment is one of the more advanced things you can try and improve to get that edge.
We're seeing as technology moves forward, then it's really being able to work with athletes and their capabilities, and it's becoming of increasing importance.
It would be great to remain here and continue with this research. That the future is really bright for it. I think personalisation is the future, and I think we're making waves here at Loughborough.